Hi everybody, and welcome back to Do Me a Solid. In today's video we are going to be creating a cardboard box using the sheet metal function in SolidWorks. Okay, so as with any SolidWorks design, you do have to start with your design intent. And there's several definitions of what design intent is. In this case, I'm using design intent as the method of manufacture. So we're using this design intent to determine how we're going to design this box for manufacturing. So SolidWorks sheet metal feature allows you to flatten the pattern, and you can see exactly where I started. Everything stems from this rectangle right here. Now that's on this particular type of box. On different cardboard boxes, obviously there's different ways for them to be manufactured. This box, when flattened out, doesn't start the same way because of the fact that it's actually wrapped around, and this panel on this end is stapled over here to this piece. You can see that in the example here. So when I turn this around, you can actually see where it folds in here, and this normally gets stapled. There's a couple staples on the side of the box. So that can be for another video, but for this one we're going to be focusing on this box right here. Okay, so to start designing the cardboard box, the first thing that we need is a base flange. So in my case, I chose the top plane, and I started with this rectangular sketch. After I made the rectangular sketch, I went ahead and went up to the sheet metal tab here, clicked on base flange, and then it gave me all of these extrusion features and sheet metal parameters. So I overrode the default parameters and created my own, but these will be determined by your manufacturer or whoever the supplier is that's going to be making the box, so you understand their box thicknesses / tolerances. After you create the base flange and it's extruded, you officially made your part into a sheet metal piece, and this is going to give you the ability to flatten it like I did at the end of the intro. So after this is where we begin to create all of the flanges that come out from this base flange. Okay, so the next step after creating that base flange is to create the edge flanges that are coming off of the side of the box. To do that, we're going to go ahead and hit Edge Flange under the Sheet Metal tab, and then we're going to select one of the sides and then choose the direction we want that flange to go in. Okay, now as you can see, the bend on this is kind of ridiculous, so we're going to go ahead and hit uncheck Use Default Radius. We're going to go ahead and click 60 thousandths. So what we're going to do is take a look at this down here. I'm actually going to hit Control 4 so we can get a better look of what these options actually do. Okay, with the flange parameters, we do have a couple of options here. So first things first, I want to go to flange length because I want to adjust that to 3 inches. Now, I'm going to zoom in a little here. Pay attention to the top of this here. What this is going to show us is how the length of this flange is determined. For the first one, what's going to happen is it's going to determine the 3-inch length from a line drawn from the bottom here to an intersecting line to the outside of the actual flange. So that's going to determine the 3 inches that happen here. Otherwise, if you click the central one, which I usually use, it's going to be the 3 inches from the top of the radius that we specified. And then on the last one, it's from a tangent line. Now, this is handy when it comes to having angles greater than 90 degrees. What that means is anytime you have a bend that's greater than 90 degrees, there's basically going to be a tangent line drawn along this curve, and that curve is going to be, or that line is going to be perpendicular to this edge flange. The length is going to be from the top of this to wherever that imaginary line stems from on that tangent. Okay, so I'm going to go ahead and set this back to 90 degrees so we can start talking flange position. So as you can see here, there's different areas that the flange can be positioned off of this base flange. So I'm going to go left to right and explain what they are, except this one because I don't use it for this particular command. So the first one is going to be the outside of the flange lines up to the base flange, which cuts into your base flange. The second option is to have the inside of that flange line up to the outside of the base flange, which also cuts into it. For our use here, I'm going to use the outside, which is the base flange is attached to the outer radius that we specified earlier. Again, there's also the tangent radius to bend, which is the one that if you are using a bend that's greater than 90 degrees, it's going to create that tangent line, and that's going to help you determine the position of your actual flange. So in our case, I'm using both the radius and the flange. Okay, so the next thing that we have to do is we have to apply this to the other 4 sides. So we'll go ahead and hit Control 7, which puts us in isometric view. Then we're going to go back up here and select the remaining edges. Since we already specified 3 inches earlier, all of these are going to be the same length. Go ahead and execute. And there you go. We have 4 flanges for the box. Okay, so the next step is going to be to add some reinforcement flanges to the inside of the box. And what we're going to do is we're going to go back up to the edge flange again. We're going to go ahead and click an edge, point the direction. As we can see, the same thing happened with the radius, so we'll go ahead and click off default radius, add the radius we think is going to work, and then this is a point that's going to be able to display the inside-outside tangent bends that we talked about earlier. So what we're going to do is we're going to put the flange position of this one on the interior, so that way you can see that it's being bent towards the inside of this and within this wall. So we want it to be contained. If we chose any of the other options, they would put it beyond this, so that wouldn't work out for us. So we're going to use that option for the flange position, and then we're going to go ahead and select the other 4 edges here. 3, and here's the last one. And then I'm going to go ahead and put a length of 2.5 inches. And what these are going to do is they're going to reinforce the inside of the box for us. So now we have all 4. They're the same length. Go ahead and execute those. Okay, the next step that I have in the cardboard box is the radius that I added to each one of these flanges. So that's a regular feature. Go ahead and fill it. Click on the edge. Click on the edge. Click on the edge, and click on the edge again. Now I'm going to make this a generous fillet. Now this can be a design aesthetic, but it really doesn't serve anything as far as the structural integrity of the box. Again, this is a design element. This still creates a structure that's going to reinforce the next step. So earlier I used the flange position to be outside of the base flange and include the radius. Now the reason why I did that is because of the fact that the next step requires us to create a hem, and that hem is basically going to create a rolled edge that's going to come over and into the box. And then ultimately what we're going to want to do is put some holes in the bottom and some tabs in this closure so that it locks into the box, and that way it won't come open, and we have the reinforcement from the inside edges. Okay, so let's go ahead and create that hem. So go up to the sheet metal tab, click the hem tool, and we're going to select our first one, and then we have the direction specified from there. So there's a couple options on this one, just like on the flanges. So what we have here is we have the hem starting with the material inside of the edge or bend outside of the edge, just like the flange. So let's go ahead and Control 1 so that we can go into the side view here. So we have the material inside, which means that the edge of that roll is going to be at the top of the flange, or you have it above, just like the flange material. And then we have different types and sizes here. We're only going to focus on the first 2. The first one is a closed, which is basically a crease. So you would have a crease that literally has the box folding in on top of itself. Depending on your design, you could use it, maybe not. The most common one that we're going to use and end up using is the regular curve tool here, so the open, because what we need to do is we need it to go above this piece and then sit inside all the way down to the bottom here. So how we do that is we go ahead and put the parameter here. Let's go 80 thousandths, for example. And then we'll notice in our design here that there's a bigger gap than 80 thousandths will allow to happen here, and that's on the inside. So I'm going to go ahead and make that a little bigger. I'll go ahead and put it to 100 thousandths, and then I'll go ahead and increase this to 3 inches just like we had before. And then we can take a look at the bottom, Control 1 again, and then we can see that comes up a little short, so I'll just go ahead and notch it 100 thousandths, and that's close enough. And what that's going to do is I'm going to create the hem that's going to come over these, and the next step will be to add the tabs and the slots to the bottom of the box so that we can lock it in place. Go back up here to the edges and select the other side as well, because we have 2 of these that we need, and then switch the direction if it's the wrong way. The arrows help you manipulate that, so left and right will allow you to do that, and now we have 2 hems that fold into the box. Okay, so now that we've created our hems, let's go ahead and add the tab and slot into it. So in the sheet metal tab, go ahead and click tab and slot command. Okay, now this might be overwhelming at first, but it's really not that complicated once you actually get down and do it. So I'll walk you through it very carefully here, step by step. First things first, we got to click the edge that we want to put the actual tabs on. So that's going to be the bottom of our hem. Then we're going to go ahead and click the surface that we want it to pierce. So if you turn it over, we want this face because we want those tabs to pierce in. Now, the offset tab, you can determine how far in from the edge you would like them to move. So I'll show you how that works here. Distance 2, if you want to make them equal and move them in further. So those determine the offset from the edges. And then we want equal spacing because we want to make sure that we have X number of slots. 3 is a good number. You can use 2. Either one of those works. The length will determine how long the slots are and whether or not they go all the way through and pierce through the piece, or if they will actually be longer than that. So you can determine that with this. And then you also have height suggestions here. So you can do it blind, which will determine the length beyond it, up to surface, which is what we were aiming for, and then offset from surface, which will send it backward from this surface. And then another cool feature here that I realized not too long ago is that you could actually create radiused edges on these, or you can create beveled edges on these, and then straight edges. For the sake of this example, we'll go ahead and use the beveled edges. And then I also think I want to increase the length of the tabs. I'm going to make them 0.5 inches just so that we have a nice solid length for those. And then you can create a second group for these, so hit new group and do the same thing on the other side. Click the lines and basically repeat the process. And we've linked the groups together by clicking this button right here, but if you unclick them, you can give it special parameters to whatever new group you add. So in this case, we're actually done. So we'll go ahead and hit the execute command, and we'll go take a look at what we've done. If you look at the bottom here, we have some slots, we have some tabs, and the process is complete. Okay, next we're going to put the lid on the box, and what we're going to do is the same thing we did on the sides. We're going to use the edge flange. We're going to do it a little differently than we did those sides though, because there's a couple more things that we have to do to make sure that the constraints are right on this one. So first things first, we'll click on the edge, give it the direction as we did previously, unlock the default radius, add our own. Okay, and then what we're going to do on the flange length is we're going to go up to vertex. So up to vertex allows us to click on the hem, and that's where it's going to stop the box. So this is handy because if we decide to change the length and width of the box, this lid will always be covering to the edge of that hem. So that's kind of nice to have as a feature. Now, one thing we do have to pay attention to, Control 5 to get it to the top view, but we'll notice here that the hem that we created earlier is overlapping the lid, and we don't want that. So we're going to go ahead and hit Edit Flange Profile. And then what you can do here is you can take that sketch and move it inward. Obviously, we're not going to do it that way. We'll go ahead and constrain it from that flange base edge to the lid. Go ahead and do 50,000 so we can have some clearance, and we're going to do the same thing on this side as well. We'll go ahead and move this in. Go ahead and smart dimension it to this. Now what I want to do here is I want to hit equal, and then we can go ahead to the first dimension, click on it, and it'll be the same dimension every time. So now these are linked, so every time that you change this dimension, this one will automatically update with it. 50,000 should be good, so we'll go ahead and click finish. See how we did. Okay, now if we look at the box, we do see a little bit of a problem, because that means that the lid is coming below the hem that we created, and that doesn't look very good because from the back we had to cut into it. Why that happened? Well, let's go ahead and investigate, because I have a feeling I know. Go ahead into the edge flange, and then take a look at the flange position that we used. In all the other examples, we used above. So that would make it come up to the same edge as the hem, but it would also not create any slots on the side. So we'll go ahead and use that one. Had we used the other two, it would have created those notches on the side of those cutouts, and we would have had a not so great looking box. So let's go ahead and complete that. Control 7 for the ISO view. Okay, so there's a couple of different ways that we can do this next part. What I'm going to suggest is, since we need to kind of have the interior of this open so we can have some visibility inside the box for the next flanges we have to create, I'm going ahead and use the unfold command here. And the fixed face that I'm going to use is obviously the bottom. The bend I want to unfold is this front one. We'll go ahead and execute. And then as you can see, it unfolded the box so that we can see inside of it. Now, we could have used the section view to do a left and a right to try to get all the edges that we're trying to complete here, but I'd rather just unfold the front of it and go ahead and use that the way it is right now. So we'll go ahead and do the edge flange. We'll select the flange out here on the side when it lets me. We'll do it down as usual. Untick default radius, put our own. And then for the flange length, we'll go ahead and hit up to vertex, and we will match it up to the hem down here that we already made. Click back up over here to the edges, select the second edge, so we have both of them in there. Go ahead and execute. And then we do have this edge open now, but we can do one of two things. We can either keep it and fold it back up using the fold command, or we can just go ahead and delete it because the feature that we just created is not dependent on it. So we'll go ahead and do that. Control 7 for ISO view. And to finish off the cardboard box, we're going to go ahead and create this front flange. Now we're going to do this without using the unfold command like I did previously. We're going to go ahead and do it without it and see what the difference is. So if you hit edge flange, click that front edge, define your direction, unclick your radius for default, and then what we're going to do is we're going to do up to vertex again, but we're going to zoom in, we're going to click on the bottom, and we're going to use the vertex on the bottom of our hem here as our constraint. Now, with the unfold command, you probably have a little better idea of the interference that could be happening within the box. But luckily for us, SolidWorks also has a great detection system in sheet metal that tells us whether or not there is any interference within the pieces. So we'll go ahead and click this out, and then it looks good, but I do want to point out one thing. Go back to Edge Flange, right click, and hit Edit Feature. I do want to point out that this is one of the first times that we've actually used it where the flange position is not outside of the actual flange edge that we selected. So in this case, we wanted it to be with the material on the inside so that it didn't interfere with anything else as far as the front edge of the box. If we would have clicked this one, it would have hit it. Interference, interference. And just so you could see it, if you click off on it, you'll get a warning telling you that it's essentially intersecting itself. So we'll go ahead and click Edit Feature. Go back to Material Inside. Execute. Control 7. and we are all set. And that is how you build a cardboard box using the sheet metal features in SolidWorks. Please like and subscribe, and I'm all for having any comments for future videos. Thanks everybody. Cheers.